After writing all of these electron configurations, you might realize that it's very repetitive, because the inside electrons, the core electrons, what you start with, always are the same. That pattern doesn't change. So we actually have an abbreviated method that we can use to write electron structures known as the noble gas configuration. So let's take an element such as calcium. And we need to write the electron configuration for calcium. Well, we could do, let's start from the beginning, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and that's fine. But what we can also realize is that the electron configuration from the beginning, 1s2, all the way up to 3p6 is actually the same as another element. If we stop our electron configuration early, just at the beginning here, this is actually the electron configuration of a noble gas, argon. So what we'll do is write that noble gas down in brackets. So I'll do brackets, argon, and this indicates that calcium has the electron structure of argon, which is right here. Then, well, it still has 2 more electrons, right? So argon has 2 fewer electrons than calcium, so we have to account for these last 2 electrons, which are the 4s1 and 4s2 electrons. So we'll write that down, and we'll have argon 4s2. And this is our abbreviated electron structure. So all we do is find the noble gas that comes before our element. So here's calcium. We go back, and the nearest noble gas that came before it is argon. We write that noble gas in brackets, and we write whatever comes after it. So let's try one more example. So this time we'll write the noble gas configuration for tin. Please pause the video and try to find this one for yourself. So what you should get for tin is here on the periodic table, is we find the noble gas that came before it, which is krypton, or we could always go to the end of the periodic table and up 1 row. So we get krypton in brackets, and then we write the electron configuration for what comes after krypton. So the next row is the 5s1, 5s2. Then we have 4d10, because we need to move all the way across this 4d row, and we're still not at 10. And then we have the 5p's, 5p1, 5p2, and we're at 10. So this is going to be our noble gas configuration. Krypton, 5s2, 4d10, 5p2. And again, remember that by putting krypton in brackets, it's summarizing all of the electrons and where they are that came before and up to the noble gas krypton.